so I'm going to just do this problem for you, and hopefully the steps make sense. So you have 2x is less than negative y minus 3. So we want to solve for y. So we want to get y by itself on one side of the equation, preferably on the left-hand side, so that way it looks familiar. So we need to identify the two things that are happening to our y. So the first thing that I'm going to say is that in front of our y we have a negative, but we should recognize that that is really a negative 1 in front of our y. Okay, so that's really a negative 1. So I want to think about the different things that are happening to our y using our order of operations. So we want to solve for y. There are two things happening to our y, and they happen in order according to your order of operations, your PEMDAS, right? So we have multiplication happening here, right? Negative 1 times y, and then we also have subtraction happening here. And according to our order of operations, multiplication comes before subtraction. Okay, so the first thing happening to our y, and let me move this down just a little bit. The first thing happening to our y is that it is being multiplied by negative 1. As a matter of fact, let me write this a little bit differently. The first thing happening to our y, right? The first thing happening to our y is that it's being multiplied by negative 1, right? That's a multiplication sign. And then we are subtracting 3. Okay, then we're subtracting 3. So in order to undo that, right? So here's us, right? We're starting down here. This is us. Okay, and we want to get back to our y. So we need to undo all of the steps in between. So the first step that we need to undo is we need to undo subtracting 3. So in order to undo subtracting 3, we need to add 3 to both sides of our equation. Okay, so negative 3 or minus 3 plus 3 creates a 0 pair. So that no longer adds value to our problem on the right-hand side. But we had to do it to both sides, so now that plus 3 goes over to the other side, okay? So we have negative 2x plus 3. The reason that I did not combine these is because I cannot, okay? Negative 2x is a variable term. Positive 3 is a constant. You can't combine them, so we just write negative 2x plus 3. And then we still have is less than a negative 1y. So now the next thing that we need to undo is we need to undo this multiplying by negative 1. In order to undo that, we have to divide by negative 1. And we need to divide both sides by negative 1. Okay, so now that creates a 1 pair. Okay, over here, negative 1 over negative 1 just creates a 1. And then on the right-hand side, we just have 1y or just y. On the left-hand side, I'm going to split that fraction into two fractions to make it a little bit easier to see. So we're going to have negative 2 over negative 1x plus 3 over negative 1. Okay, so I just took this negative 1 and split it into two fractions, like that. I can simplify. So I know that a negative over divided by a negative is a positive. So 2 divided by negative 1 is really positive 2 divided by negative 1, right? These negatives cancel out. And I know that 2 over 1 is just 2. So this whole fraction is actually just positive 2. So we have 2x. And then 3 over negative 1, well, that's a positive over a negative. That's negative. So this whole fraction will be negative. And then 3 over 1 is just 3. Any number over 1 is just itself. So we have plus negative 3, right, is less than y. So I know that adding a negative is the same as subtracting. So really you're done here as far as solving for y. But I want to get this in the form y equals mx plus b, right? So that way I know how to graph this. So I'm going to just move my y. I want to put my y on the right-hand side. So I'm going to put my y, over here, right? The alligator is eating the y in our solved equation, so the alligator still has to be eating the y in our new equation. And then on the right-hand side, we have 2x plus negative 3. Okay, you could change that plus negative 3 to just minus 3, but I'm going to keep it like that. So now we have an equation in the form y equals mx plus b. right? So we have 2 is our m, and negative 3 is our b. And I know you know how to do this from here. So you would plot your y-intercept at negative 3, and then you would rise over run 2 over 1, right? So if you wanted to think of that 2 as 2 over 1, right, you would rise 2 and run 1 from negative 3 on your y-axis, right? And then you'd get those 2 points. Then you would have to know that since this is greater than, or since this sign is greater than, right, not greater than or equal to, it's going to be a dotted line. Okay, matter of fact, let me just try and draw this out real quick, right? So we have a dotted line. So we have our y-intercept at negative 3. I'll do that in yellow. Y-intercept at negative 3, right, for our b. And then we're going to rise 1, 2, and run 1. So our next point will be over here. We're going to do a dotted line because it's just greater than, okay, not greater than or equal to. So our line is not included, or the points on our line are not included in the solution to this inequality. And then because it's y is greater than that, right, we are going to shade above our line, okay? So the shading happens above our line. So hopefully that helps. And this applies to like all of the problems that you're going to do, okay? You're going to want to ask yourself, what variable am I solving for, right? You're always going to solve for y, so that way you can get it in this form. You need to have y on just one side of your equation. You're going to ask yourself, what's happening to my variable and in what order according to order of operations? And then you need to undo each of those by doing the inverse operation of those to both sides of your equation. And then if you have to at the end, you want to manipulate it so that way it's in the form y equals mx plus b, and you can easily recognize what your m is and what your b is. And then from there, I know you can graph this. I know you can do the graph from there, okay? All right.